Science at SHS is about tapping into children's innate sense of curiosity. Why do things happen in the way that they do? Learning and teaching in science embraces this idea of a shared journey of discovery between the pupils and teachers. Our most important resource is our staff. The science team consists of 22 dedicated, knowledgeable and passionate teachers from a diverse range of backgrounds and experiences who have one thing in common. They want to deliver learning experiences that unlock the natural curiosity and allow pupils to flourish and realise their potential in science. We emphasise that journey of discovery through practical activity and have a first-class technician team to offer and deliver that practical support. Even during the current restrictions, we are still offering practical opportunities to our pupils, particularly at GCSE and A-level. We have 13 well-resourced laboratories. Our teachers are innovative and embrace evidence-based practice in their teaching. Retrieval practice is used extensively in lessons, and the team keep up to date with the latest cognitive science to ensure all pupils in their classes make optimum progress. I'm now going to hand over to my colleagues Rachel, Hannah and Matt, the respective heads of biology, chemistry and physics, to give you more detail on the individual GCSE and A-level courses.
In Year 9, the girls start their GCSE in biology, and they start with cell structure. So they learn all about cell structure, cell division, and then transport across cell membranes. They then move on and study organisation. So that's where we look at larger systems. So we look specifically at the digestive system and the enzymes that operate within that. And we look also at the circulatory system. And possibly too, we look at non-communicable diseases, so coronary heart disease in particular. As girls move then into Year 10, they either choose to study combined science or separate science. Either way, they move on and they look at inheritance, variation and evolution. So students that study separate science will actually study that topic in a little bit more detail. So for example, students that study separate science will look at protein synthesis, which is a topic that's kind of described briefly at GCSE as part of the separate science course, but then is touched on in a lot more detail at A-level. And so girls that study combined science, for example, they wouldn't study that unit, which is just a couple of lessons. The girls then go on to study the next topic, which is ecology. So we finish the year with ecology. And again, there's a unit within that called food security that the girls that study separate science learn about, whereas the girls that study combined did not. And that gives us a little bit more extra time to study the other content in a bit more detail and just to consolidate it more regularly. So the girls then enter Year 11, and so we have two more topics to finish off. So we look at communicable diseases, and then we move on and look at homeostasis. And then the girls will sit their exams in at the end of Year 11.
For GCSE, we start it in Year 9, and Year 9 will cover content that is common to both separate and combined science, because they don't make their choices about which course they're going to do until towards the end of Year 9. So they'll cover basics about atomic structure, the periodic table, and then also a topic about rates of reaction. In Year 10, they'll have chosen whether they're going to do separates or combined. The separates and combined course cover pretty much the same topics. It's just that in combined, you'll study slightly less in each of the topics, mainly less calculations. So things we cover in Year 10 would include fundamental chemistry, so things about atoms again, bonding, structure, the properties of matter, different types of reactions, energy changes, and also organic chemistry, so looking at organic molecules and how we extract them and how they react. In combined, the main difference you'll find in Year 10 is that you do a lot fewer calculations. So you'll do only one of 3 modules on calculations, whereas in separates you'll do all 3. And then in Year 11, we study energy changes in reactions. We also look at some analysis, and we look at how chemistry applies to real life. So looking at things like making fertilizers and why that might be useful. And again, if you're studying combined, you'll still do those topics, but just a little bit less content in each of them. In both courses, you have to do a set of required practicals. These are practicals where you will study the method, you might do some questions around the practical as well, and then in your exam you could be asked about those practicals, and there are 8 in the separates course and only 6 in the combined course.
So we start GCSE physics in Year 9, and this is a chance for us to really start thinking about the subject a little bit more systematically and applying our knowledge from maths and chemistry to physics. We start the year with energy, which is a really fundamental concept. And then we move on to the particle model of matter, which links really well with chemistry, and we finish the year with waves. All of the content in year 9 is common to both the separates and combined. In year 10, we cover 2 big topics really. Forces, which we break up into 3 separate parts. So we look at motion, which is caused by forces. Then we look at Newton's laws, which explain why forces occur. And then we look at specific examples of forces like atmospheric pressure or moments, for example. And then we finish the year with electricity, where there's a whole number of required practicals that we do, looking at the different rules around circuits. In year 11, if you're a separate student, we start with space, which isn't covered in the combined course. And then we end with atomic structure, which covers radioactivity.
I love science because we have a myriad of problems facing humanity, and science can solve those problems. And I am a passionate science teacher and leader of science education because I really want to equip the next generation to be able to solve those big problems like climate change, like world pandemics. And I believe that at Surbiton we can really achieve this and send a huge army of STEM specialists out to help solve those problems.